viewers to another episode on AS your G12 exams. So in this episode we are looking now at section C of the August 2022 Science Paper 1. So section C carries 20 marks because we're expected to answer 2 questions out of 3. So each question is 10 marks. So if you do intensive revision, this is one of the easiest section in the exams. So if you can get the 20 or at least get 18 out of 20, this would help you to move towards getting that distinction. So let us start with question C1. A learner carried out a Hooke's law experiment using standard 50 kg masses and obtained the following results shown in table C 1.1. Question A. Complete the table C.1 for the values of the load N and the extension in centimeter. So this is 2 marks. So once you complete this table, you get the 2 free marks. So this is one of the common questions that comes to complete the table. So basically to fill the table, what we're doing is basically just finding the load. Now the load is weight. So weight is given by basically the product of mass and the gravity. So the mass should be in kg, but this is in grams. So we need to convert this to kg. So what we do is, how many grams and 1 kg? There are 1000. So it will be 50 divided by 1000. So this is going to be 0.05. Then this 0.05 we multiply by 10, which is gravity. Then we're going to get basically 0.5. So 0.5 newtons is the load. So in this case, this is 0.5. So similarly, for this one, it will be 100 divided by 1000. It will be 0.1 times 10 is going to be basically a 1. Then similarly, this one, it will be basically 150 divided by 1000. Then multiply by 10, we are going to get a 1.5. We go on the similar principle until we end up with a 3.5 newtons. Then we go to extension. So extension is basically what you are saying is the length change. So to find the extension, what we do is basically it's the actual at a given load, then minus the length at the beginning when the load was 0. So it's basically 10. So it will just be at a particular load minus 10. That will be the extension. So let's say, for example, start with the first one. When the load is basically 0.5 newton or 50 grams, the extension will be basically 12 minus 10, which will be basically 2. Then this one, it will be basically 14 minus 10, which will be 4. Then similarly like that. Then we have 9.5. Then we have 10.5. Then we have 11. So basically, this is how you complete this table to get these 2 easy marks. We move to B. Use the values obtained in A to plot a graph of extension against load. So basically, what is key here is to identify which one is y and which one is x-axis. So always the first one is the y-axis. So this is y. Then the second one is the x-axis in physics. Don't swap. Then how do we graph this? So we need to identify the interval. So starting from 0 going all the way up to 11. So what we can do is increase these by 2. So this is 2, 2, 2. So we have from 0 all the way. The next number divisible by 2 is a 12. So it will go up to 12. So that is the equal interval. And I'm increasing it by 2 units. Then in terms of the load, which is the weight, it's moving from 0 all the way to 3.5. So what we can do is we can increase it in the same interval of 0.5, then all the way up to 3.5. Then once we do that, this is basically the x-axis, this is the y-axis. Then we can proceed to use the graph. So what is important, ensure that the graph is increasing, units are increasing in the equal interval so that it is scaled properly. Okay, so let me move to the graph paper so that we plot this. Alright, so we have the graph paper that has been labeled clearly to help you without wasting much of your time. So what you notice in this case, the x-axis is basically the load, which is properly labeled here. Then we have the y-axis, which is also properly labeled here as the extension in centimeter. So what is important is label it clearly. So once we do that, we can proceed to start plotting these points. So what we have basically 0.5, 2, and starting from 0 and 0. So remember, when it's not starting from 0, don't start from 0, but in this case it's starting from 0, 0. So it's this point, this is the first point. The next one is basically 0.5, 2. So 0.5, 2. Then next is basically 1, 4. So 1, 4 is basically this one. Then the next one is basically 1.5, 6, which is 1.5, 6, this point. Then we have 2,8, so 2,8, which is this point. Then we have 2.5, 9.5, so 2,9.5 instead of 10. So you see basically coming to 9.5, which is just basically at halfway of that. Then next is 3,10.5 instead of 3,12, so 3,10.5, which is somewhere here. Then we have basically 3.5, 11, 3.5, which is somewhere here. So 10.5 is here, not there where I put area. So it's basically here. Okay, so once we do that, basically you are going to join this using a straight line. So let me use the black. So when you join this one, you notice that from here it is a straight line. So from here to there is basically, this is a straight line. Then you start bending up to here. Okay, so here to here it is basically a straight line. So we're going to have a graph like this. Then after you have a graph like this, basically you get the 4 marks. So basically you get the 4 marks, which is already 6 out of 10. Then see on your graph, show the elastic limit. So basically the elastic limit is at the point where these are the direct proportionate relationship stop applying. So you notice that it ends at this point. At this point the graph starts curving. So at this point, this is where the elastic limit is. So it's at that point. That's where it is. Then, and that is 1 mark, which is already 7. We look at question D. From the graph, show the load N where the extension was 9 centimeter. So where the extension was 9 centimeter. So what we do is basically we come to this graph. Then a 9 is somewhere here at the half. Then we draw this line where it's meeting this point. Then once we come to there, somewhere 9, it will be here. Then we will bring this line down. So when you bring this line down, you will notice that this point will be approximately at, if we use the ruler nicely, it will be basically approximately 2.3 newtons. So 2.3 newtons will be basically the load. So use the ruler and draw a smooth line, just one line using a pencil, because I'm sketching here, so it may not be as clear as possible, but you do that, then you get the 2 marks. Then let us look at question E. State the condition under which Hooke's law is obeyed. So Hooke's law is only obeyed under the condition that we don't go beyond the elastic limit. So under the condition that we do not pass the elastic limit. So as long as we don't pass the elastic limit, the force applied to a spring will be directly proportional to its extension, as long as we don't pass the elastic limit. So once we pass the elastic limit, the spring is permanently extended. Then even if we remove the load, it will not return back the way it was before adding that load. It will remain permanently stretched, or it will just reduce a bit. So basically, this is how you answer this question to get the 10 marks. So please join me as I look at question C2 in the next episode.